Okay, so in today's lesson, what we are going to look at is we are going to determine intervals on which a function is increasing or decreasing, and then we are going to apply the first derivative test to find relative extrema min or max. Remember, this is just the min or max, the relative min or max of a function. Okay, so first thing, looking at this graph down here, this function is decreasing, which means, and we talked about this a long time ago, but this is a little refresher, if your function is decreasing, if I would draw in those tangent lines, that means my derivative is less than 0. So when your derivative is less than 0, your function is decreasing. Here my function is constant, which means my tangent line is 0. So when your function is constant, your derivative equals 0. And on this side, you see my function is increasing, so if I would draw in those tangent lines, they're positive slope, which means when your function is increasing, your derivative is greater than 0. So we're going to use the fact that our derivative tells us whether a function is increasing, decreasing, or constant today. And we're going to use calculus to do that. So let's look at another picture here. You see here this function is increasing, meaning the derivative was greater or positive, greater than 0. Here the function's decreasing, the derivative is negative. Here the function's increasing, the derivative is positive. So think of those tangent lines. The other part, finding those min and maxes today, is right here. If your derivative goes from positive to negative, you have a maximum. So if your function goes from increasing to decreasing, you would have a maximum. So your function's increasing, it's decreasing. In the world of derivatives, that means your derivative went from positive derivative to negative derivative. If your function is decreasing and goes to increasing, that's a minimum. So my function was decreasing and then increasing. That's a minimum. In the world of derivatives, that means your derivative was negative, and then your derivative was positive. So your derivative was less than 0 and greater than 0. A couple little special cases here. These kind of say the same thing. You can read through those if you'd like. Again, derivative less than 0, greater than 0. Derivative positive, derivative negative. So here's a max, this one was a min. Sometimes today when you have a critical point, you might have on each side of the critical point where your derivative is positive. That's okay. That just means there's no min or max there. Or you might have that your derivative is negative. So those tangent lines both have negative value. That's okay. Again, it just means there's no min or max. But you still would check those and you'll just find that they don't switch from positive to negative, so there's no min or max. So what we need to do now is to try this with a function. What you're going to do today, kind of 3 steps. You're going to find the critical point where the derivative equals 0 or does not exist. You're going to find the intervals where it's increasing or decreasing, and then you're going to find the local min and max and plug them in to find the y value of those. So the first thing, before you do anything, think about the domain of a function. So since this one is polynomial, I know my domain is negative infinity to infinity, because that's going to be part of our intervals today, because we're on an open interval, not a closed interval. So the second thing I'm going to do then is my number 1. I'm going to find the derivative. So the derivative of this function would be 3x squared minus 3x, and then I set that equal to 0. And then I can factor. And I get 2 critical points. Those would be 0 and positive 1. So the second step is pretty new. We're going to find the intervals where it's increasing or decreasing. So for your intervals, you have to start with your end of your domain. So the end of my domain is negative infinity. So my first interval is going to go from negative infinity to my lowest critical point, which is 0. My next interval will be between the 2 critical points, And my last interval is going to be from the highest critical point to the end of the domain. All right, then what you're going to do is you're going to put in a test point. So a test point here would be -1. So a test point's anywhere in the interval. A test point here would be maybe 0.5, and a test point here would be 2. And with this test point, this is the first derivative test, that's what you're doing here, is you are going to put this test point back into the derivative to see if the derivative is positive or negative. So if I put -1 in here, this gives me a positive, this gives me a positive, so it's going to be positive. So my derivative is positive, so my function is increasing. So my function is going up. I'm going to put 0.5 in there. So if I put 0.5 in there, that gives me a positive. That's going to give me a negative value. And you can use your calculator to look at that, but I know it's going to give me a negative value, and which would mean my function is decreasing. And then if I put 2 in here, 2 squared is 4, so that's 12 minus 6, so that's going to give me another positive value. So that means my derivative is positive, my function is increasing. So what we did is we found that my function is continuous, and here at 0 it switches from increasing to decreasing. So it's going increasing to decreasing. So I know that there is a maximum when x equals 0. And here, well, actually, let's just stop. So when x is 0, there's a maximum. So what I can do is I can find the y value to go with my maximum by plugging 0 back into the original equation. Well, it's going to be very easy. That's 0. All right, and then over here, my function changes from decreasing to increasing when x is 1. So that means there would be a minimum when x equals 1. And then I can plug the 1 into the original equation. So I get 1 minus 3/2, so that's -1/2. That is the minimum of the function. And really that's what we're going to do today. So let's look at another one. Oh, I put a trig one right away. That's okay, we can do that. So again, we're going to, first of all, trig functions, you see they change the domain, so they want between 0 and 2 pi, because if not, you'd be finding infinite number of critical points. So you're going between 0 and 2 pi. And then we want to take the derivative. So the derivative of 1/2 x is 1/2 minus the derivative of sine is cosine. And you set that equal to 0. So if I get 1/2 is equal to the cosine of x. Now you have to use your unit circle, and you need to figure out where cosine equals 1/2. So think about that. Cosine equals 1/2 at pi over 3. So it's positive 1/2. So then again, it would equal 1/2 at 5 pi over 3. So these are my two critical points. So now I'm going to make my intervals, and instead of using infinity, this time I have from 0 to pi over 3, and then pi over 3 to 5 pi over 3, and then 5 pi over 3 to 2 pi. So you have to find values in between those. So I would use my unit circle. You can also just use your calculator. So like I know pi over 3, I know that pi over 6 is smaller than that. Or in between there, sorry. And then 5 pi, between pi over 3 and 5 pi over 3, I could use just pi over 2. And 5 pi over 3 and 2 pi, that one you're going to have to do a little bit more thinking. You could get something very close to this. So let me show you a way to do that. Hold on one. Okay, so I pulled up a unit circle. So here's 5 pi over 3. I can use any of these two values because they would be in between. So I will just go with 7 pi over 4. That says 7 pi over 4. Okay, then you take your test points and you put them into your derivative. So the first one, you're going to have 1/2 minus the cosine of pi over 6. And the next one, you're going to have 1/2 minus the cosine of pi over 2. And then 1/2 minus the cosine of 7 pi over 4. Now you can use your unit circle or you can use your calculator. So if you're using your calculator, put that in radians. Okay, I'm going to go back to the unit circle that I had pulled up there. So my first one was 1/2 minus the square root of 3 over 2 for pi over 6. So that is going to be negative. So that means my function is decreasing. Here, the cosine here is 0. That one I know. So that is positive, so it's going to be 1/2 minus that, so it's positive, so it's increasing. And you guys can be plugging these right into your calculator instead of using your unit circle if you prefer. That's fine with me. Okay, and then this one you get 1/2 minus square root of 2 over 2. So which one of those is bigger? Well, if you need to, put that in your calculator. Like I said, you totally could do this all in your calculator. So I have 1/2 minus the square root of 2. Oh, shoot, I can't even do that on there. Anyway, I know that this one is bigger. So I'm just going to know that this one is negative. So you can put that in your calculator, and that one should be decreasing. So again, and looking at our first derivative test, we went from decreasing to increasing, which means right here is a minimum when x equals pi over 3. Okay, so what you can do then to get the y value, you have to go back up here and you put pi over 3 into this to get your actual minimum value. So if I put pi over 3 in there, I get 1/2 times pi over 3 minus the sine at pi over 3. So this just gives me pi over 6 minus the sine at pi over 3 is square root of 3 over 2. And I would leave my answer like that. If you were graphing, like when we get to graphing, go ahead and get the decimal approximation. But for today, I don't have a calculator. Obviously, I don't know how to use the one on my computer, so that's how I'm going to leave that, whatever that decimal value is. So pi over 6 minus square root of 3 over 2. So pi over 6 minus square root of 3 over 2. All right, so then the next one, I go from increasing to decreasing, so that means right here is a maximum when x is 5 pi over 3. So my x value is 5 pi over 3. And then to get my y value, I go back up to my function, my original function. I'd get 1/2 times 5 pi over 3 minus the sine of 5 pi over 3. And so that gives me 5 pi over 6 minus the sine at 5 pi over 3 would be a negative square root of 3 over 2. So this becomes plus. So that's my y value. Again, if we're graphing, get the decimal, but today we're just finding these points. Okay, so I found the critical points. I did the first derivative test. I found that my function was decreasing, then increasing and decreasing on those intervals. And then I found the values of the min and the max. So what I'm going to do, I'm going to end this video but I'm going to make another one with more examples. So it's kind of up to you. You can try some of the assignment, but I will put a video with different types of problems. So on the other video, I will have just another polynomial function and a rational function and a square root function and maybe another irrational, just so you have lots of different examples. Okay, so if this video is enough for you to get started, go ahead. If not, watch some more. I would maybe try one and then go back and watch when you get to the harder problems, and we will go from there.